In this talk, I'll talk about federated cross-platform SQL processing with Apache Wayang. So I'll talk about Apache Wayang and also some of our recent efforts in terms of developing a SQL library that lets us analyze federated data sources in a platform-agnostic way. So my name is Kaustubh. I'm an assistant professor at the Indian Institute of Technology in New Delhi. I'm also a co-founder and CTO at Databloom.ai, and I am Apache Wayang's committer. So Apache Wayang is really important to us at Databloom. So at Databloom, we are building a product called Blossom that lets users create a virtual data lakehouse. It lets you connect seamlessly to multiple data lakes and data silos. And so you have a single point of access for all your data. On top, one could combine multiple data processing platforms to run their data analytics. Also, with our flagship product, Blossom Studio, one could run data analytics across multiple data sources with simple user interface. So coming to Apache Wayang. So Apache Wayang is the only open source system that provides a systematic solution for unifying analytics across multiple heterogeneous data processing platforms. So usually data processing platforms are specialized for different tasks. And when it comes to running analytics across multiple platforms, this becomes time consuming in terms of deciding which task, which platform to select for which task, and how to glue different parts of the code so that one could exploit different platforms. With Wayang, the goal is to provide a unified way to run analytics by decoupling applications from the underlying platforms. Wayang comes with a built-in optimizer that helps, that relieves the user from the burden of choosing which platform to choose to run a task on, and it uses a combination of platforms to maximize the performance. So in particular, when it comes to unified data analytics, we identify two general cases. So the first case is where one needs to run a task on a single platform, and this platform can change depending on the circumstance. And the other general case is that of multi-platform processing, where one has to use multiple platforms to run data analytics. So let's look at these cases in more detail. So the first case that we identify is that of platform independence. That is, we need to use any single data processing platform to process a query, depending on the circumstance. So let's look at an example of word count. So word count is like a hello world example for big data. And here we want to run word count on, let's say, a small size or a data that has a small size. So let's say 200 to 300 megabytes. In this case, it does not make sense to run the application on Spark. So what Wayang does is it provides a convenient API where one could write the word count application without really worrying about what underlying platform to run it on. So for instance, here's a code snippet that shows the word count example. So if you look closely in the first few lines, there's a line that says with plugin. And the plugin is basically a Java plugin. So this tells Wayang to run the application on Java. And on the bottom of the code snippet, you see a plan builder, which is essentially composed of operators such as flat map, filter, map, and reduce by key. These are also used by other big data processing platforms. And so the learning curve to get familiar with the Wayang's API is very low. Now, let's say we don't have small data, but we want to run word count on large amounts of data. In this case, it makes sense to run the application on Spark. However, with Wayang, one need not worry about how to rewrite the application for Spark. All one has to do is change the plugin. So for instance, one could now specify the Spark plugin, and Wayang would run the same application on Spark on big data. So what Wayang really enables is a platform-independent way to write applications. Likewise, one could specify different plugins for different underlying platforms, and Wayang could optimize the job based on which platform is the most suitable for that particular application. The second use case that we identify is that of polystores. And as the name suggests, polystores deal with data that is distributed across data sources. So let's look at an example join query where we have customers and orders table in Postgres, and the line item table is on Spark or on an HDFS. Now, this example is from a well-known benchmark called as TPCH, which is widely used in the database community. Now, in this case, we have data lying across two different sources, and what Wayang enables is to write the join query again in a platform agnostic way, and it would run specific parts of the query on specific platforms without having the user to glue different parts of the code and moving data between different platforms. So for instance, Wayang would do the join between the customers and orders table on Postgres and transfer the intermediate data, here labeled as JR1, to Spark. And then the Spark would continue processing the query by joining the intermediate data with the line item table. The third use case is that of opportunistic cross-platform processing. Here, we can use or exploit several data processing platforms to reduce the overall cost of processing. So here's an example from the machine learning domain where we are running stochastic gradient descent. So this is an iterative computation where we sample over a large data set and then we compute gradients. So in this case, intuitively, one may feel that it's best to run the entire job on Spark. However, Wayang can exploit presence of other platforms and again split the job into multiple tasks, which can then run over different platforms. So for instance, over a large data set, it could sample using Spark, whereas for computing gradients over a single data point, it could use Java. And by combining both platforms, Wayang is able to optimize the job and reduce the overall cost of processing. The last use case when it comes to multi-platform processing is that of mandatory cross-platform. Here, one has to use several data processing platforms to be able to process a query. So for instance, let's assume that the data is stored in a Postgres database, and we want to compute a page rank on that data. Now, in this case, Postgres is not suitable to run page rank because running recursive jobs on Postgres is not the best thing to do. Now, in this case, Wayang would still be able to push down some operations to Postgres. So for example, reading the data and pushing down projections, and then it transfers the rest of the data to Spark, which would then continue with the page rank computation. So the main computation happens on Spark, whereas operations that are closer to the data source may happen on Postgres. Now, Wayang is designed to be extensible. So it comes with a cross-platform optimizer that chooses the best platform for a specific task. It can automatically break down the program into multiple smaller tasks and then can choose the right platform for the right task. Also, in terms of supporting platforms, one could extend Wayang by implementing a driver for that platform. In terms of API, at the moment, Wayang supports two main APIs that are Java and Scala. There's a Python API that is currently under development, and we are building several libraries on top, namely SQL for machine learning and for polyglot queries. In the rest of the talk, I would talk about how we are designing the SQL library to support federated query processing. So to support SQL queries on top of Wayang, we are leveraging Apache Calcite. That's a well-known Apache project used by many other big data platforms such as Apache Hive and Apache Flink. And the idea is that we could combine the SQL capabilities of Calcite with platform independence of Wayang and come up with something very powerful that could help us analyze data across federated sources. So for instance, one could write a SQL query combining data from a CSV file, data on Postgres or MongoDB or Redis on cloud, and run the computation in a platform agnostic way. So Wayang in this case would then pick the right platform for the job, or it would do the best possible option with the platform it has. So Apache Calcite is an extensible query planning framework that has components for parsing SQL query. It has components that could rewrite and optimize query, and it supports various data connections. And the best thing about Calcite is that it is pluggable, and all these components are extensible. So the way we use Calcite in Apache Wayang is that we use Calcite to parse the SQL query. After parsing the SQL query, we get an SQL node, which is essentially the abstract syntax tree or the logical query plan for the SQL query. Once we have the logical query plan, we use Calcite's rule-based optimizer and cost-based optimizer to transform that into a physical plan. Once we have the physical plan, we then implement a Calcite to Wayang plan translator that translates each operator in the abstract syntax tree to an operator in the Wayang plan. And once we have the Wayang plan, we can then run this as a regular Wayang job without really worrying about what platform Wayang would choose to run this query on. So let me show you an example of how this works. So let's say we have two tables on two different data sources. So these sources could be large CSV files on HDFS and maybe, let's say, a Postgres database. And let's, for example, take a simple query where we are joining these two tables and computing some aggregations. So the first thing that we do is we use Calcite and parse the SQL query and generate an intermediate physical plan. Now, in this intermediate physical plan, we have the relational operators, for example, table scan, project, and filter. And for each of them, we additionally store properties that tell us about these operators. So for instance, for a table scan that points to a CSV file, we store the source file path. Likewise, for the table scan that points to a table on Postgres, we store information about the Postgres. Now, once we have the physical plan, we proceed in a bottom-up fashion where we traverse this plan on a per operator basis. And for each operator, we translate that to a Wayang plan. So for example, we start with table scan. And here the table scan points to an orders table, which is lying on a CSV file. In this case, we translate this to a text file source operator in Wayang. Likewise, for the Wayang project, we translate this to a map operator. For the table scan that points to a table on Postgres, we create a table source operator that is capable of reading tables from JDBC sources. Continuing this example, the filters and projects are translated to filters and map respectively. A join is translated to a join operation in Wayang, and an aggregate is translated to a reduce by key operator in the Wayang API. Now, in all this, the important thing here is that we generate the UDF for these operators based on the relational query. Now, once we have the Wayang plan, we basically submit this to the Wayang API, and one can now run this query across different platforms without actually specifying which platform it should be run. So in sum, combining Apache Calcite and Wayang enables us to do federated cross-platform SQL processing. So at one side, we leverage the SQL ability of Apache Calcite, and on the other, we exploit the platform independence of Apache Wayang. And we can now run federated cross-platform SQL queries in the best possible way. So like other open source projects, Wayang greatly depends on the community. So I encourage all of you to check out the website. There's also a dev list that you can subscribe to know all the updates that's happening in the community. I would also encourage people in this field to participate and help us develop Wayang. And last but not the least, I would like to thank all contributors from Databloom.ai, IIT Delhi, IT University of Copenhagen, TU Berlin, and BIFOLD for contributing to Wayang.